Please welcome Thaddeus Fortenberry.
All right, thank you. So, Wei-Han and Miles have done a great presentation talking about the technical details of what we are doing. And in this presentation, what I want to do is take us back to the why behind what we are doing as a company. So I want to start off by talking about what is happening in the auto industry. Now, I had a different word than turmoil in this, but the marketing team suggested it might be too harsh. But the bottom line is that the auto industry is changing fundamentally. And there are three major reasons. One is the shift to electrification, going from gas to electric vehicles. Another reason is because there's a complete change in manufacturing technology, which is reducing the price and increasing the volume of production of cars. And then the third area is the role of compute in cars. And a lot of this is being driven by the autonomous vehicle, the technology around autonomous vehicles. Now, we can't really help on the first two items, but we can help on the compute side. The first thing that we need to address is that we need to dramatically increase the rate of innovation. China is setting a very high bar. All the OEMs are moving so quickly, and we need to make sure that all of us, whether it's in China, whether it's in Europe, US, wherever, can increase the rate of innovation. We also need to make sure that we are integrating decisions throughout the platform, software, hardware, vertical development methodology, and it's not just about software and the processor, it's across the entire platform. So we need to look at this a little bit differently. Historically, auto industry has been very encapsulated. You had a team that was working on a particular technology, and that's all they ever touched. And now that is changing, and so it's platform-wide. Another issue is that the automotive industry and the robotic industry are actually very, very similar right now. Even the FUSA capabilities, while there's different ISO specifications, they are actually functionally quite similar. Now, I think this will change in the future. I think that when you compare a car driving down a road to a humanoid that's opening the refrigerator for you, that there might be different functional safety concerns. But right now, it's very, very similar. So what we are doing to address this and address the cost pressure, so we have innovation, we have cost, we have increasing power demands, and the performance demands and the power stays about the same. We are betting that open ecosystem is going to help solve these problems. So we are investing in making sure that we are prepared to deliver on the requirements for this industry, for these industries. We have been building a comprehensive functional safety team, and this has been integrated throughout our engineering teams. So the first generation, we've had to do a lot of retrofitting because we started with the data center part. So we had to do a lot of retrofitting, and I'm sure many of you know, that is a very painful way of achieving ASIL certifications. So what we have done is make sure that we have integrated our functional safety experts throughout the organization. So as we are developing the follow-on parts and designs, that functional safety is considered from the very beginning. We have then been collaborating with all of the OEMs, or at least most all of them, and many of the tier ones. And the reason why we're doing this is because we know, Tenstorrent knows how to build excellent silicon. You've just seen presentations about what we're achieving. But what we needed to make sure of is that our designs also meet comprehensive automotive requirements. This is quite different. And we needed to make sure that we brought in experts who have years and years of experience in this, reviewed our designs, and signed off, said, you know what, this is going to work for us. So we are leading this transition towards open hardware. And we're doing this in not just the RISC-V, it's a combination of the hardware specifications, the supporting software specifications, and also, as Wei-Han was talking about, our open chiplet ecosystem. So let's get a little bit deeper in the robotics strategy here. So if you are comparing between a more traditional model where you go to another silicon provider and say, hey, just sell me a chip, I don't care how it works, I don't need to have any vision of what's happening in the drivers or anything like that, and then they add whatever margins they want to it, this model is going to be very difficult to be successful. And the reason is because you want to make a part that's customized for your automotive robotics deliverables. I only want the silicon that I need in that to meet those requirements, no more, no less. I want to make sure that I have full access to the data and everything that makes this part their part. So we have identified that having the OEMs move away from the traditional model to a model that is more flexible, there's an issue, and it requires that we have a standard for chiplets. And so, as you saw in previous slides, we've been working very closely on defining that standard and making this openly available to everyone. We hope, and our goal is to make sure this is a cross-vendor, vendor-independent, cross-geographical region standard that can be used and leveraged. So, specifically around automotive, I want to discuss why does chiplets matter in automotive? And because I always remind everyone that I talk to that chiplets are not new, and this has been around for a while. But what is new here is that we're trying to say we want to have a standard across all vendors, across all geos. And we want to be able to provide the tools that enable any company who wants to build a chiplet, and not just a chiplet, an automotive chiplet that meets automotive requirements, participate in the ecosystem. But the real reason why we're doing this is to lower the cost of the end product. Now, it's a little counterintuitive, because if you look at a package cost of a monolithic die versus a chiplet die, the cost of the package is going to tend to be more expensive. However, over time, you also have the ability to, say, switch out only one chiplet that you want to innovate. You don't have to re-tape out an entire monolithic die. You can mix technologies. I can have 5A and 3A appropriately in the same package. But there's another issue as well, and that is if I can use, everybody talks about chiplets with PowerPoint, and in PowerPoint, chiplets are super easy. In reality, this is the reason why we are doing OCA, is because we're trying to enable this industry. And what we want is to have, if I have a low-end vehicle that only needs driver assist, I just maybe want one AI chiplet. That's it. As I go up in functionality, I might have 2. I might have 4. And if I go all the way up to data center, I will have tens, hundreds, thousands of that same chiplet. So for the first time in automotive history, we actually have the opportunity for volume. When we go and negotiate with a fab on a wafer price, our whole story is changed, because this actually is volume. And then if you add into that we're talking about a global standard with multiple vendors that are making their own combinations of chiplets, that is real volume, and that's how you get that cost down. So this is such a fundamental vision that we've been having on this. We knew that having this open standard is important. So we started out and we pulled in all the different standards bodies, the components that are relevant, and we started working on our Open Chiplet Atlas. We then had a small group of initial reviewers, and in this context, it was automotive experts, and they reviewed it. They are continuing to review it, and we are making sure that it is meeting the requirements of automotive. Whether it's tier ones, OEMs, we have a number of core reviewers. Now, once we do that, we have been working very closely with IMEC's Automotive Chiplet Program, the ACP, and we will be publishing this to not just the IMEC, but also the entire world. We intend to make open chiplet architecture available to anyone, everyone. Additionally, there is a similar project called ASRA, which is the Japanese standards effort, and we are also working on this. We feel very strongly that we need to collaborate as an industry on this open chiplet approach, and that will give us the most opportunity for flexibility and the most opportunity for volume. Now, I also want to point out that a lot of times when you talk to someone who's got scars from years of working in automotive, that this world has really changed a lot. It used to be that you would have a 28 nanometer piece of silicon that would work in some weird microcontroller somewhere in the car, and you had a team of people that were just working on that one little microcontroller. It cannot be more different than what we're doing today as an industry. All of the compute in modern vehicles are consolidating. The whole shift is to consolidate more and more and more. It's because it's saving money. The development methodology has all of the software developers working in the cloud. I was talking to an old colleague of mine who's now at AWS, who said, by far, the number one company that is using AWS ARMS servers is automotive. That's the largest industry that is using AWS ARM. And the reason is because it matches the architecture that's on board, right? And so it's much easier if you have that architecture matching both on the front end and the back end. So when we are talking about investing in automotive, it's not just about the onboard compute. It's also an enabler for the back-end infrastructure. And this is an important point. There are many of us here in this room who have gone through the pain of the x86 to ARM servers over the last 13 years. So this actually is a great way to enable RISC-V in the data center. That's a little counterintuitive because when we talk about automotive, we're actually including data center in this. So let's talk about the open versus closed. What is this going to take? So the first thing is that, and I want to say we planned all of this, but we didn't plan this. We happened to be at the right place at the right time talking about open. And it just so happens that governments are really into open right now. Everyone is trying to figure out how, with all the geopolitical change that is happening right now, how can they have better control over their own destiny? And open is the answer. When you have a proprietary solution, it is inherently aligned to one particular geographical region, wherever it might be. Open is everywhere. It's open. So that's great. Another thing that's nice is that in automotive, we have a comparatively shallow history code. When we did the x86 to ARM thing, we had 50 years of code that we had to deal with. We've only had autonomous vehicles for the last 5-6 years, right? So there's not this huge tail of history with software. So that helps with this transition. Standardization is actually the initial step. And what we are going to see is this going to enable a boost of innovation in the types and combinations of chiplets. And this is exactly what we want. Because as an industry, as all of us coming together, what we want to see is this enablement and this innovation around the IP that solves these major problems that customers are asking help on. So how do we do this? How do we succeed? Well, the first thing is our RISC-V parts, our Tenstorrent cores, all of the supporting ecosystem, that has to be feature parity. If somebody has a particular security design, then we need to be able to support that. Or some I/O requirement, we need to be able to support that. We must have full functional safety that meets expectations. That means full documentation, comprehensive safety manual, etc. We need to make sure that we have verification platforms. Miles was talking about Project Atlantis. A RISC-V development system where you can put a Tenstorrent core in. You can start developing software right now. You can start developing software right now on our emulation solution. So there's a path to taking this from software emulation all the way to being on product. And that is going to enable the software ecosystem. So the one thing about this list, we know how to do this. As an industry, we know how to do this. There isn't some mystery that needs to be innovated here. This is just work. So what we have done is we have created a portfolio of IP and silicon that is supporting this path, how to get this work done. I won't go through all this because Wei-Han and Miles did a great job on it, but you can see that we've got RISC-V, we've got Tinsic, we've got system IP, so you do not need to license anything from a proprietary, we're trying to make this as open as possible. At the bottom right, you will see that we are also developing what many call as a reference platform. This is our ARIA base die. We have a base die and we have a AI chiplet. And we are rushing to get this out as quickly as possible to complement that next step, emulation, Atlantis, and then the actual silicon for bring up. Now, one of the things that I want to point out is that our goal, and this is somewhat unique, is we are selling what I would call a reference hardware, and I want to use the base die as an example. The base die has all the things that you would expect. You know, there's a security subsystem, there's a safety subsystem, all the things that you would expect in a typical automotive platform. But one of the things that you run into when you talk to OEMs, and as I said earlier, we've talked to every OEM, and early on especially, the conversations all started out with, we're going to do what Tesla did. We want to make our own silicon. However, what you see is, you remember the slide that Wei-Han showed about how much it now costs to make silicon. I think it was around $600 million for the 3 nanometer slide, on his slide. These car companies, remember, they have 3 big crises: batteries, manufacturing, silicon development. They have a lot of asks to invest in. So what we've done is we have made this base die using information, using requirements coming in from these companies. And if they have something, even if the design is not quite exactly what they want, let's say that they have their own NPU, their own AI chiplet, or their own AI technology, we don't need to argue with them and say, no, ours is better. What we say is, great. You can take that soft IP, you can remove our AI, and you can replace this AI with your own. This changes the dialogue, because what this means is that these OEMs can build their own piece of silicon. They can use the design services of who they choose, and they can make their own branded piece of silicon. They don't need to innovate on things like PCI or memory controllers or infrastructure. They just want to take out that secret sauce and put their own in there. Now, there's obvious limits. You know, there's size limits, there's complexity limits, but this actually solves a lot of problems that these companies are trying to make a competitive part. And that's what we're doing with ARIA. When we say we're open with everything that we are doing. We're making it available so these companies can make the flavor of that part that they need to meet their requirements. So in the end, we are delivering silicon. We are addressing robotics and automotive. Our silicon design is taking the requirements from each of these companies. We've built a design which we're very proud of, and this also is with the complementary server data center parts. We are in the process of building, and we will be providing a comprehensive functional safety solution. And as you saw on some of the other slides of my colleagues, we have not just right now what our part looks like, but a roadmap of moving forward and continuing to enable an innovation over time for these companies. We are leading the transition. We are actually, I would phrase it even stronger, we are betting our company on open. open hardware, open software, and developing a partnership to where we can all work together to bring this as a community to address these issues around automotive, robotics, and even the data center. So the race is on. We know what we need to do, and I think we're well positioned, and through our partnership ongoing, I look forward to all the progress that we're going to be making. Thank you very much.